All right, so I thought I would do a video on the substitution method. So we're being asked to solve by substitution in this section. This is section 4.2. So we have two linear equations, and we're going to use the substitution method. So what you want to do is get one of the variables on a side by itself. This one just already has x on a side by itself. So you know that the x in one equation and the x in the other are going to be the same at the point of intersection. You're kind of imagining this and you're looking for that point of intersection. And then the equal sign there means that 2y minus 3 is the same as x. So what we're going to do is right here where the x was, we're going to be replacing it in a minute with the 2y minus 3. So we'll put it right there where the x used to be. Now, when we do that, we now have an equation that just has y's in it. So we're ready to just solve this equation using what we did back in chapter 2. So I'm going to distribute and get negative 8y plus 12 plus 3y equals 2. Okay, now here the negative 8y and the positive 3y are like terms that need to be combined. They're on the same side of the equal sign, so you just are combining like terms. That would be negative 5y plus 12 equals 2. And then from here down, should go a little more quickly. We need to get rid of the 12, so we'll subtract it from both sides. That's going to give us negative 5y equals negative 10. And then I need to take or get rid of that negative 5. So I'm going to do that by dividing by negative 5 on both sides. So I wind up with y equaling positive 2. All right, now all that tells you is that the y coordinate of this point is 2. Now I need the x of that point. So what I'm going to do is go back to the equation x equals 2y minus 3, and right where that y used to be, I'm going to now replace it with 2. So I wind up getting that x would be 4 minus 3, or 1. All right, so I think the x is 1 and the y is 2. Now, what I can do to check it is use the bottom equation. Let me get rid of these circles here so you can see it. We use the top equation to find the remaining value, so I can use the bottom equation to check it. Okay, so that would be negative 4x plus 6, and that sure enough would be 2, so I know that's right. So that's your answer. Now on Alex, I've noticed a lot of times it'll say this and this, and have you put in the x value and the y value. Really, they should be asking you to fill in the ordered pair. Okay, so that's the overall process, but we kind of started with one of the variables already on the side by itself. That doesn't always happen. Okay, so with question number 2, we're being asked which variable from which equation is easiest to get on a side by itself. So you don't always need to get the y on a side by itself. You could have the x by itself like we did on number 1. But on number 2, do you see how there's a 3 in front of the x, a negative 2 in front of the y, 6 in front of x, and then here there's a understood just 1? That's what you're looking for, is an understood 1 or negative 1. Okay? In front of a variable. That's going to be the easiest one to get by itself right there. So y in the second equation is easiest to get by itself. Because the y has only 1 in front of it. So 1 is the coefficient. Okay, so if it has a 1 or a negative 1, it's going to be the easiest one to get by itself. All right, now the problem says to go on and solve using the substitution method. So what I'm going to do is take that second equation and get that y by itself by moving that 6x out of the way. Make that a little bigger. So I'm going to subtract that 6x from both sides. So I'm going to have the equation's going to become y equals negative 6x plus 6. Okay, so I'm going to put that together with the first equation. So let me rewrite it down here. So we have 3x minus 2y equals negative 7. And now we have the equation written, so one of the variables is on a side by itself. Okay, so y is by itself. At the point of intersection, the y should be the same, and y should equal negative 6x plus 6. Okay, so what I'm going to do is take that equation, 3x minus 2, and right there where the y is, I'm going to replace it with negative 6x plus 6. Okay, so I'm going to distribute at this point, because now my equation just has x's in it, so I'm working on just using what I learned in chapter 2. I'm going to distribute. Okay. Then I'm going to, since 3x and 12x are on the same side, I'm going to combine these like terms here and get 15x. I'm just looking because I'm noticing I'm going to get a fraction, and I'm just kind of surprised. So I'm just checking to make sure I didn't mess up on anything here. I don't see anything wrong. Oh well. So now I'm going to add 12 to both sides. Okay. So that's going to get me to 15x equals positive 5. And now I have to divide by 15. So I'm going to have a fraction. I'm going to wind up with x being 1/3. Okay. I'm always surprised when I get a fraction. It doesn't happen that often, so I just wanted to double check and make sure I didn't mess up. But I kind of ran back through it and don't see where I made a mistake. We'll check it at the end and make sure we're right. All right, so now what we do is we take that x equals 1/3. We can plug it into any equation that has an x and a y in it. But the best one to plug it into is the one that you had transformed so the variable was on a side by itself. So right there where the x is, I'm going to be plugging in 1/3. Okay, so that's going to be negative 2 plus 6. So y should be 4. Okay, so I think the answer is 1/3 4. All right, now I used the second equation to find my y coordinate, so my check is going to be using the first equation. 3 times 1/3 minus 2 times 4, and see if I get a negative 7. So that would be 1 minus 8, which would equal negative 7. So now I feel better. That's correct. Okay. All right, so let me do a couple more. All right, so here's a few more to do. Okay. These two are kind of ready to go. They've already got the y, a variable already by itself. Okay. This one doesn't, and that y would be the easiest one to get by itself because it has an understood -1 in front of it. And then here I'm going to clear the fraction, and then that'll make it pretty easy to get by itself as well. Okay. All right, so let me take a look at question number 3. Remember, you can pause the video, work it out, and then check it. Okay, so at the point of intersection, the y should be the same. I've got the y by itself on that second equation, and I know it's got the same value as 5x plus 1. So I know that I can just replace the y with 5x plus 1. So I'm going to take that top equation, and right where the y used to be, I'm going to put 5x plus 11. Okay? I'll have to distribute and work towards solving this just like I did in chapter 2. So that's 4x plus 60x plus 12 times 11 is 132 equals 4. Okay, these are like terms, so I'll combine them. 64x plus 132 has to be 4. And then you know how we go from here. We're going to subtract 132. It's going to leave us with negative 128 equaling 64x. Then I'm going to divide by 64 to get the x by itself. So I like the look of this one. That turns out to be a negative 2. I always feel better when it turns out to be a whole number, an integer, but it doesn't always do that. All right, now we're going to plug that back in, that negative 2 back in right in this equation. Because right there where that x is, I know x at the point of intersection has to be negative 2. So right there, I'm going to put a negative 2 and just work this out. All right, so that's negative 10 plus 11. So y turns out to be 1. So we're thinking this, negative 2, 1. Now your check should be to go to the first equation and put a negative 2 where x is and a 1 where y is, and see if you get 4. And you do. Negative 8 plus 12, that's going to be 4. So that's for sure correct. Okay, number 5 is kind of like that, but it has a fraction that you got to deal with, but you know how to do that with your calculator. It's really not any different. Y's by itself, these y's should be the same. And I know that equal sign is telling me that y and 1/4 x plus 3 can be interchanged. So right there in that second equation where you see the y, I'm going to put 1/4 x plus 3. Okay. All right, so I'm going to distribute that. X minus 1x minus 12 equals 8. So this is an understood 1x minus 1x. So that's really gone. That's going to be 0, isn't it? So I have negative 12 equals 8. We usually don't write that 0. We just think 1x minus 1x would be 0, be gone. Now you see how that's false? Okay, the variable disappeared, so that meant special case. So you should be thinking when you see the variables gone, special case, turned out false, so your answer should be no solution. Okay. All right, just a couple more. Number 4 is a little bit, oops, I hate it when it does that. Let me just clean this one up because it slipped back up. Okay, moved it too quick. So that was x minus 1x minus 12 equals 8. This was an understood 1, x minus 1x, so that's 0. Get negative 12 equals 8. Okay, so the variable disappeared. That's telling me, special case. The remaining statement is false, so I know this is the case where I have no solution. Okay. All right, so that's, if they use the special language, that would be an inconsistent system. No solution, inconsistent. Okay. What's really going on is those lines were parallel. All right. So let's go ahead and take a look at question number 4. 4 is a little harder than 3 and 5 because the variable is not by itself yet, but the y in the second equation should be what you try to get by itself because it has just a coefficient of 1 in front of it. Okay, so I'm going to go ahead and subtract 2x to move it to the other side. I get negative y equals negative 2x minus 6. Okay. Then I have to divide by negative 1 everywhere. So when I do, I get y equals positive 2x plus 6. Okay. So now what I'm thinking is my first equation I was just going to leave as is, but my second equation is now y equals 2x plus 6. So that step right there just turned question number 4 into question number 3. So do you see how I have the y by itself? And then I can think about how the y in the first equation and the y in the second one would be the same at the point of intersection. So I ought to be able to put that 2x plus 6 right in there for y. Okay, so that's what I'm going to do. I'm going to take 3x plus 5 times the 2x plus 6 has to equal 17. So 3x, now I'm just getting ready to solve that like I do in chapter 2. 3x plus 10x plus 30 would equal 17. So the 3x and the 10x are on the same side. I'm just combining like terms. So I get to there. And now I'm ready to just finish it up by subtracting the 30. Okay. That gives me 13x equals negative 13. So when I divide by 13, I get a negative 1. So x equals negative 1. All right, now what I'm going to do is go back to that equation where I had the y by itself, and right where that x is, I'm now going to put negative 1. And I wind up with y equaling 2 times negative 1 plus 6. That's negative 2 plus 6, which is 4. So I think it should be a negative 1 for x and a 4 for y. Okay. Now you can check these. I'm going to stop checking them, but you can check it by plugging in for the x and the y in both equations and just seeing whether it works. And it would. It does. Okay. All right, and then with number 6, the fractions make it feel harder, but what you can do is go through and multiply by the LCD, the least common denominator of those fractions. So the LCD of 2 and 4 is 4. So if I multiply by 4 everywhere on that first equation, I'll clear out the fractions. So 4 times a half would be 2x minus 4 times a fourth would be 1y equals 4 times 1, which is 4. Okay. So now the first equation doesn't have any fractions. I'm going to work on getting that y on a side by itself so I can use the substitution method since they asked me to use substitution. So I'm going to subtract 2x from both sides. Okay. I'm left with negative 1y equals negative 2x plus 4. And then just like on that previous question number, I think it was 4, we had something very similar. I'm going to go through everywhere and divide by negative 1, which gives us y equals positive 2x minus 4. Okay. So I'm going to take this 2x minus 4, and I'm going to put it in for the y in the second equation. Okay. So 6x minus 3 times what I had for y, and y and 2x minus 4 are interchangeable. So I'm just replacing that y with 2x minus 4. Then I can distribute, and I get 6x minus 6x plus 12 equals 12. So this is another special case, isn't it? Because these are going to cancel out, add up to be 0, gone, and I get 12 equals 12. I don't get x equals 12 or y equals 12. The variable disappeared. That indicates to me that I have a special case. Okay, but now this one turned out to be true statement. It's an identity. It's always true. So that tells me that I'm going to have infinitely many solutions. All points on the line would be the solutions. I don't think they make you write it formally, but it would look like this. The solution set would be all the ordered pairs such that, and then right here you would write one of the equations. Usually it's the one that's simplest. It turned out when that happens, what's going on is you really have the same line. But I think what they asked for, from what I could see, is infinitely many solutions, and then they want you to put the special language. So these would be dependent equations. So that's the special case. So this would wind up being like 2 lines. I'm not saying this is what they'd look like if I graphed them, but number 6 is 2 lines, but they're really right on top of one another, where number 5 is a pair of lines that are parallel. Okay. All right, got one more I want to do. I'm just doing the video because I want you to be able to go back and look at it if you need to, and over Thanksgiving. All right, so now we're going to set up a system of equations. Our job here is to find the two numbers. One number is 3 more than 4 times another. Not trying to remember anything about that, just getting the gist of it. Their sum, the sum of the two numbers is 133, and my job is to find the numbers. What they're asking you for is what you let your variables be. So I'm going to let x be one number, and I'm going to let y be the other. Then we have 2 sentences, and we're going to make an equation out of each sentence. Okay, so go back. All right, so one number is 3 more than 4 times another. That word is going to be your equal sign. So I'm looking at that first equation. One number, I'll let that be my x. Then I need to translate 3 more than 4 times another number. So y is the other number. Remember how you start where the variable is? Then you do 4 times that. That's 4y. Okay. Then you come back and do 3 more than that. So that would be plus 3. And it should be really 4y plus 3 like that. If it had said 3 less than 4 times another, you would do 4y, and it would have to be minus 3. Okay. So that's the first equation. Now look at the second equation. Here's the verb is, that's the equals. And it says the sum of the two numbers, their sum is 133. So it equals 133. And sum means that you would add them. So there's your system. And then it says use substitution to solve it. And thankfully they did, because that's the easiest thing to use here. So you can pause it and think about how to get it set up. Now we're ready to solve. So the x from here equals the x from here. And 4y plus 3 and x are interchangeable. So I'm going to put a 4y plus 3 right there. I'm going to add the y and get 133. So 5y plus 3 equals 133. So just work on solving that using Chapter 2 techniques. Okay. So I'm going to subtract 3. I get 5y equals 130. Divide by 5. And I get y equals 20. What happens? Let's see. 5 goes in there 26 times. Yeah, I think that's right. All right. And then I need to find the x. So x would equal 4 times that plus 3. I'm going to replace the y with 26. So that's going to be 80, 104 plus 3, which is 107. Okay. So one number would be 107 and the other would be 26. Notice their sum does turn out to be 133, so that's a good check. Okay, so that's how you solve by substitution.